So the idea of you guys doing the table of values, some people were noticing that there was a couple of weaknesses about that method, right? Because if you weren't told the values of x to use, a quadratic might look like this, right? But if you chose the wrong x's, you might plot these points here. Is that going to look, if you've graphed a quadratic that looks almost like a straight line, it's not really going to look quadratic, okay? So looking at all of the stuff in the textbook, I tried to come up with a method that's always going to allow you to draw a quadratic nice in the middle, and you're going to be able to draw the full curve. So I came up with this. It would have been 2020 during COVID. A better method, I think, of graphing a quadratic involves steps that you can remember with the letters DIVA. This method I invented, yay me. However, you'll perform the steps in the order DIV. So I like the DIVA thing, but it doesn't exactly work DIVA. You have to do it in the order DIAV. So let's grind through it. How do I graph quadratics with the DIVA method? Make sure it's written in this form. Y is equal to something x squared plus bx plus c. So I'll stop here to give you time to write. What does D stand for? In DIVA, it's direction. So if you look at the coefficient of x squared, so the number in front of x squared, if the value of that is positive, the quadratic will curve like that. It'll scoop down like a U shape. If it's negative, then the quadratic is concave. How do you remember concave and convex? Does this look like the mouth of a cave, this one here? So that's how I remember concave. It looks like the mouth of a cave. And the opposite of that is convex. So D stands for direction. If the number in front of x squared is positive, it scoops down like a U. If it's negative, it goes up, points up, it's concave. Can you get that explanation for what D is for DIVA down? What does I stand for in DIVA? Intercepts. There's two kinds of intercepts here. How do you find the x-intercepts? You make y equals 0 in your quadratic, and you solve for x using any strategy that I've taught you. So you could factorize it and then solve using null factor law. You can use quadratic formula, okay? The solution or solutions for x are where the quadratic cuts or touches the x-axis. So as you've seen with quadratics, sometimes there's two solutions. That means the quadratic's going to cut through the x-axis 2 times. If there's one solution, then the quadratic just touches. So you'll have a situation like this. If there's one solution to your quadratic, it just touches. If there's two solutions, it's going to cut through the x-axis like that. And the last option, if you get no real solutions, which isn't going to happen in your test, okay? But if you get no real solutions for x, that means that the quadratic, that's the x-axis, it's hanging out, it's floating above it. You can't answer that in year 10 yet, okay? So guaranteed in your DIVA question, it's going to be one of these two things. You're either going to get two solutions or one. When you make y equals 0, solve for x. How do you find the y-intercept? You make x equals 0 and you find y. That's where the graph is going to touch the y-axis. Okay? I'll give you some time to get down to there. So that's di for DIVA. We've done D, We've done I. Right, unfortunately it diverts away from the DIVA, what is it called when you've got those letters, that shortening thing. Here we go A now, axis of symmetry. Work out the answer to what x equals negative b on 2a is. That's what the letters were up here. This x value is the location of the axis of symmetry. That's like where the mirror is for the quadratic to be the same on either side. Draw a dotted line up and down from this x value on your Cartesian plane. Quadratics are symmetrical on either side of that dotted line. So that's A from DIVA. And deal with V now. So DIAV. What does V stand for? V is the vertex. So you just found x is equal to negative b on 2a. You substitute that into your original quadratic equation and you find y. What is the point of that? That tells you where the tip is. So some of you were doing the table of values and you're like, well, I've got a dot here and I've got a dot here. Where's the tip going to be? I don't know, it could be anywhere between those. No, with my method, you're going to know exactly where the tip is. It's guaranteed, okay? So I know that's a lot. I know that right now you're not going to be the biggest fans of that method. But when you try it out, when I demonstrate it, you might see why it's one of the more popular videos on our channel. Because it always works. I don't like giving steps that work sometimes or in perfect conditions. Really, the only time this is going to fall down is if you get no real solutions, but that's beyond year 10 level anyway. The example's too far down. I'll give people time to get that. You're almost up to the end? Just a little bit? Where are you up to?
Still up to
3. Can you just work out the answer to x is equal to negative b on 2a, and then I'll demonstrate it, and then I'll scroll back up after. All right, let's demo this ish. Is that what people call that now, when you can't say the real word? Draw the following quadratics on the same set of axes using DIVA method. All right? Sorry? Which one? Where? Okay, I'll leave it a bit more for everyone. I should do a beat to play when there's writing time. That'd be sick. Just overly bass. Just clip. This is my thinking. A subwoofer, like one of those Sony like party speakers. This would the iPad would just. Question? You done?
It doesn't say, but is the fountain also square?
Yeah, the fountain is square. Alright, can I demo it now? You've got a little bit? Alright, let's demo that. Draw the following quadratics. I'm going to do it with those different colors. Draw the following quadratics on the same set of axes using DIVA. I'm going to go A here. What did D stand for? Direction. First check, is this quadratic here written in the form ax squared plus bx plus c? Yeah? A is currently 1, B is 2, C is -3. So it's written in the right form. So how do I tell the direction? I look at the number in front of x squared, which is 1. Is it positive? So I know now that the direction is this. A normal quadratic scoops downwards. Okay? That's direction. I, intercepts. This is the most effort that you have to put in because it calls back to maths that I've previously taught you. I is the intercepts. How do I find the x-intercepts? I make y here equals 0. So my equation is going to look like x squared plus 2x take 3 equals nothing. Can I sum and product factorize this? What are the factors of 3? 1 and? Is there a way I'm going to get 2 with 1 and 3? Is that possible? So what are the factors of 3, 1 and 3? What combo of positives and negatives can I do to get positive 2? -1, positive 3. Good. So that factorizes to x. Take 1. X plus 3 equals nothing. Now we've got null factor law because do both of these things equal 0? So x take 1 could equal 0 or x plus 3 could equal 0. So x would be 1 or x is going to be -3. Do we have two solutions here? So that quadratic is going to cut the x-axis how many times? Twice. At 1 and at -3. Okay? We know the direction it's going to go, so we have some idea that it's going to look like that, but you need more dots. That's what DIVA is for. We've done I. How do we get the y-intercept? If I make x equals 0 in the equation, y is equal to x squared plus 2x take 3. If I make x equals 0, what's that going to look like? It's going to be 0 squared plus 2 lots of nothing take 3. What's y going to equal here if I've done all that? negative 3. What does that tell me? The graph is going to cut the y-axis here. See, we've got scaffolding. You're building it up slowly. Axis of symmetry. The axis of symmetry is that x is equal to negative b on 2a. What was b? B was 2. So it's going to be negative 2 on 2 lots of, what was a? 1. Negative 2 over 2, that's negative 1. So that's telling me when x is negative 1, which is here, it's the axis of symmetry. The graph is going to be the same on both sides of this mirror. Okay? I'm setting up the mirror for both sides. And what was V? What did V stand for? V is the vertex. And that asked me to put this back in the equation. So y equals x squared. It's going to be negative 1 squared plus 2 lots of negative 1. Take 3. What's negative 1 squared? 1. What's negative 1 times by 2? Take 3. What's 1 take 2? Negative 1. Take 3. Negative 4. So what is that telling you? On the axis of symmetry, which is that x is equal to negative 1, y is going to be negative 4. So I've got dots to trace this. Because it's a quadratic, what can we say about the shape of it? Is it different on both sides or is it the same? It's the same, so I could put a dot here. So now do I have a bunch of points that I could trace a quadratic through? So you could laugh at my attempt, but that's fine. It's a iPad. Can you see how that doesn't rely on you having the x told to you? Okay, it's always in the middle. Okay, that's the first one. I want to do the red one. Let's do the working out up here. D for DIVA. What is in front of x squared for the red one? Negative 1. So what direction is it going to be? Is it going to be concave or convex? Concave. It's going to go like that. Intercepts I. I'm going to make that negative x squared plus 4x take 4 equals nothing. Okay, I've got negative out the front of x squared. If I remove that as a factor, negative 1, I'm going to have x squared. What would that 4x become if I've divided it by negative 1? Negative 4x. What's that negative 4 going to turn into if I've divided by negative 1? Positive 4 equals 0. Can this be factorized? Yes, 2. It's a perfect square. Okay, so it's negative 1 x take 2 squared equals nothing. This is a null factor law now. Negative 1 can't be 0, so you'd write negative 1 can't be 0. But the other option is or x take 2 or x take 2 equals nothing. What's x going to be if x take 2 equals nothing? 2. Is there any other solutions there? So is that going to cut twice or is it just going to touch the tip? It's going to touch once. It's going to touch here. One time. Okay. Axis, we need the y-axis. So negative 0 squared plus 4 lots of nothing take 4 equals y. What's going to be left over there? If I've substituted 0 as x. Negative 4. Y is going to be negative 4, so it's going to cut the y-axis there. That's I done. Axis of symmetry, A, x is equal to negative b on 2a. What was b in this equation? What's the number in front of x? 4. So it's going to be negative 4 over 2 lots of negative 1. Negative 4 on negative 2. What's negative 4 divided by negative 2? So the axis of symmetry is going to be here at positive 2. Which makes sense because isn't that where it touches? It touches at 2. And then vertex, I plug negative, plugging that number in there, squared, plus 4 lots of 2 take 4. What's 2 squared? 4, but there's a negative on the outside, so you've got negative 4. What's 4 times by 2? Take 4. What's negative 4? Add 8, and then take 4 again. 0. Doesn't that double confirm that the vertex should be touching at that point? So you've got a quadratic that touches there. Just try to draw it as curved as... And that's too V-shaped. Something like that. Okay? That's DIVA. You have one question of that in the test, and you have one of using the table of values. If this is too complex for you, you won't get full marks, but if you draw your quadratic with a table of values, you'll still get most of the marks. I'll take 1 off, okay? But that's it. Okay? You're working on whatever it says on the timeline to practice DIVA. I'll scroll that out because that's freaking intense. But that's it. That's my method, okay? So I'll pause that.